Alright, well, back on the CCD-V701 Camcorder. Complete cap replacement. Trying to get some of this stuff done. This thing's been here for way too long. And yeah, trying to get caught up on some of this stuff. So, as previously mentioned, I've got some photos that I took here. And always try to get a good picture of the circuit board. And so this is one that I took with the flash. You can see how washed out it is right there in the center of the screen. But you can actually zoom in and make out the values on a lot of these capacitors just in case you make a mistake. And then I've got some other, like this is the same shot with no flash, just in case I can't make some of those out. So I've done that basically for both boards with and without the flash. Now these boards are connected, as you can see, by a single ribbon cable right there. So I've got the pictures of the boards, and then I also draw a road map for each board. This is the SS134. SS134 right there. There's all the capacitor values and should be location or direction of the capacitors, the positive and the negative. I always put a little line where the negative is, and then if it's a radial leaded cap that goes through the board, I put an R either next to it or on the capacitor. And then this is going to be the, which one is this board? This is the VA64, and it does mention VA64 somewhere on this board. I did see it. I just can't see it at the moment in time. Oh, there it is. Duh, right in front of me, right there, VA64. Let's go ahead and get a good close focus on this, and I'll put it in manual focus. And then I'll back this back off. It'll stay focused that way. So once again, there's the road map, and it's going to be looking in from this direction right here. So you can see where all these little 10s at 16, 22s at 4, those 3 right there. Yeah, so I'm probably going to speed this up. It's going to take forever to do it in real time. So I'm just going to go ahead and start popping these caps off the board, and then we'll have to desolder the radial leaded caps. And once again, clean this thing in the dishwasher. I'm wondering, oh shoot, I see caps under this board. I did not expect that to happen. So I need to go ahead and get the Hacko warmed up here and unsolder these 2 tabs and get underneath this circuit. I'm not sure what that is. Maybe it's the head amp. I see 2 of the identical circuits. Probably not going to be the head amp. The head amp actually goes over to here. This is probably going to be the head amp circuit right there. Not quite sure what is living under there, but we'll figure this out. So hopefully, I think this is going to be part 4.1 possibly, and then installing the caps part 4.2. And once this is done, I think I can start to reassemble the camera and give it some tests and do whatever troubleshooting is necessary. If I got a cap in backwards or a wrong value, yeah, hopefully make this thing work once again. One moment while this thing warms up. The way, if possible. Alright, pretty happy with that. And trying to be as gentle as possible on that ribbon cable. It's going to get flipped around many more times. There we go, it broke free. Oh my gosh. How many caps can you jam into a tiny little circuit like that? Unbelievable. Well, there's my roadmap. So I need to populate this area down here. And one moment while I populate this area. a little too far. There we go. And so there are the capacitors. So it's got three 3.3s in each channel and 110 in each channel. So I'm going to get the phone and grab a quick picture of this. One with the flash. Sorry, two with the flash and one without. This didn't come out really good. My pencil was running out of lead, unfortunately, so it kept spinning the things around, but I can certainly see 3.3, 3.3, 3.3, and I wrote 10 in the center, 10, 3.3, 3.3, 3.3. So a little more than I anticipated, as usual, but I'm going to go ahead and complete this for the customer. And probably the last one I'm going to completely recap. I only quoted 4 hours of labor, and I think I really undercut this job, but I'm going to stay true to my estimate and get this thing back going for this customer. Okay, let's start. I'm going to start with this board over here. I want to go ahead. It's got the least number of capacitors on it. We'll start by twisting off all of the surface mount caps first, and then I'll just unsolder the leaded or radial leaded electrolytics. And then once again, it's going to have a visit with the dishwasher once everything is said and done. And then hopefully tomorrow, after it's washed completely and dried, I will repopulate the board with replacement capacitors. I believe there was one capacitor I could not get. I think it's a 0.33, so I'm going to have to use a 0.47 in its place. It's probably going to be fine. I don't think they use this in any kind of a critical timing circuit, unless it's maybe like a mute delay, something like that. So I think it's going to be just fine. All right, like I said, I'm probably going to speed this up just so you're not watching me strip capacitors off the board and reapply caps for 45 minutes. Okay, let's get this party started. So on this board, it does have a bunch of surface mount caps on the bottom, so I'm not going to be pressing directly down on those. I'm going to actually hold this up and put my finger under each capacitor as I twist it off. Pressure down and just twist to fatigue the leads. Normally you'll hear a little pop, and then it'll come right off just like that. Okay, well I think I got them all off. I'm just doing a quick look-see on the board. I don't see any surface mounts that I missed, but I still have to pull off the radial leaded electrolytics. So there is the bunch of caps. That's a lot. So that was like 18 minutes of nothing but removing capacitors. And I do have a couple of concerns. Let me find a pointer. How about a nice pointed test lead? This is very concerning to me right there. One moment while I macro this. Hang on. Okay, I do have it in the macro mode right now. And this is a bit concerning because this is all corrosion. If any of this made it through a plate through, because this is a multi-layer board, then the game's over at that point. It doesn't look too bad. Normally when you get plate through contamination, the leads right here will actually turn black. The coating, like that one right there, might be a problem. And a lot of times these do not go all the way through the board. This is a multi-layer board, which means it may have more than one center conductor in the board. So once we get it in the dishwasher and washed off, we'll know a little bit more. And if that's the case, I did have the customer prepay the parts. I haven't had him contribute any labor to this repair whatsoever, but that actually doesn't look too terribly bad. It looks about as bad as these. These are all factory. They look very good. So I did see a few that I'm concerned about, like this one right here. It's got a little bit of corrosion on it. It's still liquid, so I'm not too terribly concerned. Hasn't turned the solder black. This one is liquid. I wonder, I don't think we've done this before. Let's try to find one that's really bad, like that one right there. So I'm going to put my ohm meter in the ohm range, and then I'll zoom way out, and then hopefully I can get a little bit of focus on it. That should focus in. There it goes. I'll try to get this into view, and then I'll zoom it back in about as far as I can until it starts to defocus. Wow, farther than I thought. Okay. Well, then let's bring it around town. We'll bring it over here. So what I want to do is just touch one lead to the pad and then one lead to the goo. And look at that. I read 1.7 meg ohms, and I'm not touching any pads at all. Let me try to get better focus for you. I'm sorry about that. Put it in manual, and then I will manually focus this. There we go. So the meter may be out of focus, but the business end over here is in focus. So I'm just going to touch it over there. I'm not actually touching a pad. I'm just touching the conformal coating or the resist on the board, and I'm getting a resistance reading. And I'd almost be willing to bet if I put it on volts, there would be voltage because it is electrolyte. Yeah, look at that, 0.16 volts. Once again, not touching a pad on here, 0.11 volts. That is the capacitor electrolyte actually becoming a capacitor just with the leads as I'm just touching it here. 0.2 volts. That's 0.2 of a volt right there. I'm not in millivolts. I'm actually just reading volts, DC voltage. So if I short these together, it's 0. So if I short here to here, it's probably going to be 0 because there's going to be a load on there. But there I get 0.16 volts. So that's why capacitor leakage causes such a problem on these things. Very, very sensitive inputs. So, all right, I'm going to put this back on high speed and we will zip off. Look at all those wet capacitors. I just want to show you that once again. One moment while I pause this and put it in macro. Yeah, it won't let me put it in the macro mode if it's actually recording, so I have to pause it. But this right here reminds me of like Louis Rossmann scraping all the crud off the Apple boards. Look at how wet that is. I think I have almost the same pointed probes that he uses. It's wet. Luckily, it's still wet. That's a good thing. So I'm going to pop this in the dishwasher after I pull all the leaded caps off of this board. Let's just take a look around here and see how bad it is. I think I've shown you the worst capacitors there are. And looking over here at the other board, those aren't too terribly bad. I may have started to make a sentence and then it slipped my mind. But a lot of times you can tell if a capacitor has leaked really bad because the actual solder, let's get that one right there. See how that terminal has turned black? That's been leaking for a while. That's not a brand new leak. It takes many, many months or even years for the solder to become black like that on the circuit board. But the good news is no traces lifted off the board. That's another point I wanted to make, that when you're pushing down, try to be as parallel to the capacitor as you can possibly be, twisting with a rotary motion and not twisting side to side as you're trying to remove these capacitors. Always with the downward force to ensure the possibility of not ripping a trace off the circuit board. With the downward force, it applies more pressure to the trace and the board. Some boards, especially Mitsubishi, on their DLP TVs were absolutely terrible. Why is it overexposed? I think I have it in manual exposure. Yeah, here we go, auto. There we go. Yeah, it should look a little bit better now. It's actually too much better. But some of the Mitsubishi DLP TVs I've recapped would rip the traces off the board very, very, very easily if you didn't press down on the board while you're trying to twist off the caps. Yeah, some of these left their little plastic spacer behind. Hey, you guys, get along. Come on. I'm trying to make a video here. Okay, once again, back to fast speed. I'm going to zip all these leaded electrolytic caps off the board, and then I will throw this thing in the dishwasher. And that will be the end of today's adventure, and we'll pick this up on what I say it was part 4.1. So next we'll be installing the caps, part 4.2. So this, I'm sorry, I'm going to take that again. This is part 4.1, removing all the caps and washing the board. And then part 4.2 will be reinstalling the caps. There might even be a 0.3 and a 0.4 depending on how things go. Okay, there definitely were a couple of these caps that I am concerned about. Even the Radial leaded electrolytics. That one's been leaking all over the place. Almost every capacitor sizzled as I was removing it from the board. So we'll see what's going to happen. I'm not going to hold my breath just because of, look at all the electrolyte under that cap right there. It's just wet. You go bye-bye. Almost every one of these caps has electrolyte leaking underneath it. I'm hoping this is not going to be a lost cause. But yeah, it's bad. Way worse than I expected. Okay, well, I have a load of dishes to run. So I'm going to look this over real good, make sure I got all those plastic little insulators off of the board. Some of them are stuck down. I mean, look at that. Every single, even the, like I said, the radial leaded caps have fallen into the same boat. And it's taking on water fast. So the first thing I like to do is hit this with some hot water and a toothbrush and just try to clean off all the crud that I can before I put it in the dishwasher. The main reason I like to use the dishwasher is it's going to flush the board, the multi-layers. It's not going to actually damage the layers. I've done this for years and years with no issues. But it's going to clean all of the electrolyte out of these holes, basically, out of the plate throughs over time and with hot water. I'm not going to use the super high temp wash. I'm just going to use the regular temperature wash, which I think is about 130 degrees. Even the lowest rated component on this board would be rated at 85 degrees Celsius, which is exactly 185 degrees Fahrenheit. So I'm not worried about the solder melting, anything like that. But I want to go ahead and clean this board before I start stripping the leads off of these pads, because I need to strip the old leads off of these pads before I add the new capacitors to the board. So I'm going to go ahead and prep this board and get it ready, and then I shall run it in the dishwasher. Okay, I've got my dishwasher ready to go. Let's go ahead and pause the diagnose stand video that I'm currently watching in the kitchen, and I've got my board ready right here, and I'm just going to go ahead and set the phone up so it will look down into the sink, kinda. And let's turn the light on so you can see what I'm actually doing here. So I'm just going to go ahead and start by just adding hot water to the board. And I'm just going to put it on the spray setting, but I'm just going to let it kind of drizzle on the board. Hopefully you can see that there. I'm going to go ahead and add some dish soap. Now I've just got a paintbrush here. And I'm just going to do a quick little initial scrub just to get rid of any of the electrolyte that may not want to come off with just the dishwasher only. And then I'll flip it over very, very gingerly. And we'll do the bottom side. No, I'm not worried about getting water in the switches or the jacks. And I'm going to try to show you the process when I'm done as to how I clean this off with the blower. I basically use a very small shop vac in the blower function to clean this off. I just want to get kind of a pre-wash going on here. Rinse this off really good. Don't need the jet spray, obviously. Get rid of the scrubber sponge, I don't need that. This is probably going to be good enough right there without actually putting this in the dishwasher. But I just want to make sure everything is going to be very good. So I'm going to move the camera over to here, and I'm just going to go ahead and, well, let's see. Yeah, we'll just go ahead and just lay the board down like that. I like that. So let's just see. Well, let me put the light on so we can actually see what's going on. I just want to reach under here and move the spray arm, and it's contacting. It's actually hitting that one connector, so if I can lift that connector up and put it over there. Oh, it's not cooperating there, maybe? I think that's going to be as good as it gets. And I'm going to rotate the spray arm once again. And good, nothing is touching anything. Let me find a towel here. And we'll clean out the little soap compartment. And we'll get one of these little pod doohickeys out. There we go, that'll work. Close that up. And once again, I use Pro Wash without heated dry, and we'll just start this, and then we'll come back in probably 2.5 hours and see if we get better results. Okay, let me finish my video and we'll move on with life. Okay, the board is out of the dishwasher, and I'm going to go ahead and use my little shop vac right here, as you can see. Kinda. There it is, small shop vac to blow all the moisture off of the board. So, warning, loud sounds. Okay, I'm good with that. So next I'm going to go ahead and preheat my oven to 185 degrees Fahrenheit in the convection mode so it circulates the air. I'm going to go ahead and place this directly on the oven rack for about 20 minutes with moving air to help cool this board. Remember, 185 degrees Fahrenheit is exactly 85 degrees Celsius. Now there is going to be some time it takes for the board to acclimate, and in 20 minutes I don't think anything is going to get hot enough to do any damage. Even if I had 85 degrees Celsius caps on the board, they're at their temperature extreme but not exceeded that extreme. Okay, let's go pop this in the oven and dry this thing off. Okay, so as you can see, I have the oven set to 185 degrees Fahrenheit and the convection fan is running. And so I've got the board ready here. I'm just going to pop the oven open and we'll expand that out, and we'll just go ahead and very gently set it on the rack right there. Hopefully you saw that. I didn't look to see if it was in frame. Oh yes, perfectly framed. And I'm going to set the timer to 20 minutes to 0. And then we will come back in 20 minutes and cool the oven off, remove the board, and then it's going to be part 4.2 where I actually remove all of the capacitor terminals that are still on the circuit board. So I'm going to end this video right here. Thank you for watching this extensive recap of a Sony CCD-V701 8mm camcorder from the 90s. I certainly hope you enjoyed this video. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, if you could hit that subscribe button and like this video, it really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at norcal715. You can email me, norcal715videos@gmail.com. That is the best way to contact me. Once again, please be very, very patient. So much going on at this time. Hopefully I'm going to be getting caught up in the next few months. If you try to contact me on social media, it might be weeks, months, or never before I respond. Please use the Gmail address only and be patient. Like I said in previous videos, I have not had time to check emails in well over like 3 or 4 months. And you ask, how do I have time to make these videos? Well, I make them when I have time, and I edit these at my work, which I'm an on-call electrician, but I don't have internet access to actually go online and answer emails and stuff like that. So I'm trying to maximize every free second of my life. All right, that's it. Everyone have a great day. I really, really appreciate your views, your comments, your support, and especially those who have donated to my daughter's GoFundMe page after the accident. Really, really appreciate that. Such a great show of humanity. Once again, yeah, the world is not dead yet. Everyone have a great day. Once again, thank you so much for watching. Bye-bye.